Good morning, students. Am I audible?
Yes, sir, audible.
Students? Yeah, thank you. Fine. In today's class, we'll see the looping problem which exists in the bridges, right? So the last yeah, in the last class, we were seeing the different types of bridges. Then later, I skipped this part because it requires a lot of time to understand. So I took the routers and the gateways, right? And today I will complete this learning bridge and its looping problem, how to avoid that. So one specific solutions for that is the spanning tree and the source routing. So in our syllabus, only the spanning tree algorithm is there. So I'll be going to uh, you know make you to get understand that, and one or two problems we will solve them, right? So this is what in the last class we were studying. So this kind of a scenario is there, so no issue. So suppose this original, so the first A wants to send the data to the D, right? So A wants to send the data to D. Initially both the at the bridge, right? So bridge will connect the LAN 1, LAN 2 and LAN 3, right? So the routing or the bridge, at the bridge we will be having a table called this one, right? So at this bridge, so all these tables are available at this bridge, and these tables will get updated whenever there is a transmission of frames from from the one particular device to the another particular device. For example, this is at the initial stage, right? So this is at the initial state. Suppose A wants to send the data or the frame to the D, right? A to D. So it has to come through this way, correct? So whenever it comes the packet, right? So at this bridge, so initially our table was having nothing, right? So when it crosses the, when it sends the data to the D, so it will get updated like this. So the physical A is the physical address and 1 is the port address, entry port address, right? And suppose D wants to reply to this A, right? So the direction will be like this, correct? So at that time what will happen at the bridge? So this is the port 2. So at the port 2, so MAC address of the D will be updated. So that is the D, right? Like this. And suppose the E wants to send information to A. So this is the E and wants to send information to A, right? So here, right? So earlier we were having the only one entry, right? So about the device A's physical address and the port address, port number. Now E wants to send the data to A. So there is a updation of the E and 3. So 3 is the port number of E, which is connected to the bridge through the LAN 3. Right? Similarly, B wants to send some data to C. So B is here and C is here. So it wants to send some data to C. So their updation is 1. So the port number 1 is connected to the LAN 1 to B. Right? That's why the port number 1 is here and it's connected to B. So this is the physical address or the MAC address of the device B. Correct. So this is well and good. So no issue in this. Now the problem comes when like this kind of arrangement. right? So whatever the arrangement, we were having the same arrangement, but here instead of one bridge, we are having the two bridges. So bridge 1 and the bridge 2. So actually we no need the bridge 2, but the structure itself is there like this. So if this is this kind of the structure is there, what will happen? So let's go through the problem. So station A sends a frame to station D, right? So initial, this is the initial. So A sends the data, right? So when it sends, so there is a updation of the table, right? A and 1. So this one is the port number 1 of the bridge 1, and A is the physical address of the device C, right? So the whenever the packet it sends, right? So with having the physical address A of the source and the physical address of the destination D with the payload. This is the actual data. So I'm saying the P, that's the payload. So it will be going through like this, and it will be going through like this. So as it is coming like this, so here also there will be entry of the table, right? So here also physical address 1A and the port number whatever it was there 1, so it's a 1, right? So now the both bridge 1 and bridge 2 both has the frame, this frame. So suppose this is the F1, right? F1 frame it has. So here F1 and here also F1 is there, correct? And this F1 it will be going to the D, right? So suppose the bridge 1, so this F1 will be converted into F2, sorry F3, F2 is here. So suppose it is a F3, right? And it will be going like this, correct? And F2 will be converted into F4, and it will be going like this, correct? So there is a, again updation here, right? So now there is an updation. So the both the bridges and this LAN 2 will be having the two copies. Here earlier it was having only one copy F1. Now we are having it two copies. One is the F3 and another one is the F4. And all the both the copies or the both the frames are having the same information from the same source, right? And both will forward the information to the D, right? So here I have written both bridges forward the frame to frame and improve the tables, right? So it will be reaching to the D, and when it sends back the information, right? So it will be circulating like this only, whatever the frame it is. So suppose it sends a frame like this, right? And this will be sending this way as well as this way, and that frame will be received here, and that again the frame will be going this way and this way. So it will be always in the loop, right? So we want to avoid this kind of a looping problem in the real-time scenarios, right? So one of the method is to go with the spanning tree, right? So spanning tree, what it does, it's a kind of on a graph. So that spanning tree doesn't have any kind of a loop. For example, so this is the A, so triangle you can think of, right? So this is the A and B and C. So if somebody asks you to write the spanning tree of this triangle, then what you have to do is you have to touch all the, these are the vertices are the nodes of this graph, right? So we have to touch the or connect the vertices of the nodes only once, not twice, right? So what kind of a spanning tree you can get? This is the one spanning tree you can get, right? So this is the A and B and C. This is the one kind of spanning tree. And another kind of spanning tree you can get like this, right? This is the A, this is the B, this is the C. This is the second type of spanning. And you can get one more spanning tree like this. This is the B, right? And this is the A, and this is the C. Correct? A, B, C. So this is how, so here we don't have any loop, right? So this is a completely closed loop, correct? But here we are having the loop. So if you send any information, it will be circulating within these three entities. But here, if you send the information here, it will end here only. It won't go anywhere. Or if you send here, it won't go anywhere. It will be staying here. Similarly, here as well as here. So we want something like this solution for our bridges. Right? So how to do that? So this is the one kind of solution. The second is the source routing. So it will prevent the loops in LANs connected by the bridges in source routing. So actually what they do is, whatever the frame we will be sending, right, to the destination. So anyway, the first one is we are having the actual data. See, it's a payload, right? Then we are having the source and destination, right? Suppose if you want to use the source routing, then you need to mention the LAN name, whatever the LAN is there. So for example, L1, and whatever the bridges you want to use, right, that bridge you have to use, you have to write. So whichever the LAN corresponds to this, only those LAN will accept this frames, as well as the bridges, whoever it is, B1, only that bridge will accept the frame. So in this way, we can avoid the looping using the source routing. So in our case, we will be concentrating on the only the spanning tree algorithm, right? So we'll go through the spanning tree algorithm. So very first step in the spanning tree algorithm is, first we need to select a route bridge among all the bridges available in the network, right? So the question comes, we are having some n number of bridges. So how to select the route bridge? So the route bridge you can select as a whichever the bridge is having the lowest ID, lowest bridge ID. So that will be the route bridge. Now, the second step of the spanning tree algorithm is determine the route port for each bridge except the route bridge, right? So initial bridge are the lowest bridge ID, that is already a route bridge. So accept that route bridge, whatever the other bridges we are having. So among that, we need to determine the route port for each bridge. So how to determine? So we'll be having a more route port, right? So here route port is port with the least cost path to the route bridge, right? So whichever the least cost is there, only that path or that port is called as the route port. Suppose there will be always possibility of having more than one route port will be having the same cost of the path to reach from the A to B, correct? So how to avoid this tie up, right? So in order to avoid that, again we need to choose a route port which is having the lowest port ID if there is a tie, correct? So the third step is select the designated bridge and port for each LAN. Right? So the designated bridge selection is done with respect to this information. So bridge which has a least cost path from the LAN to the route bridge, right? So here port with the least cost path to the route bridge. Here least cost path from the LAN to the route bridge, right? And designated port will be selected on the basis of this. So designated port connects the LAN and the designated bridge. So that will be the designated. So the port which connect the designated bridge and the LAN, so those ports we call the designated port, right? So the again here we might get into that tie, right? So again, in order to avoid this tie, we have to choose the bridge which is having the lowest ID in order to avoid the tie. So once if you have done this, So root bridge is identified and root port is determined, and the selection of the designated bridge and the designated port is done. Then we need to, the all root ports and all designated ports which we have identified here, we need to connect each other, right? And this connection we call the forwarding state, and the rest of the ports are called as the blocking state, right? So this algorithm you will get a clear idea when we see with the example. So consider this is a problem. So we are having the LAN 1 and the B1 is the bridge, B2 is the bridge 2, and B3, B4 and B5, right? LAN 1, LAN 2, LAN 3 and LAN 4 we are having. So B1's port is 1 and 2, and B2 1 and 2, and B3 1, 2, 3, and similarly B4 and B5 are having the ports like this 1, 2 and 1, 2, correct? So according to the algorithm, we need to first select the root bridge among all the bridges, right? So we are having the total 5 bridges. So root bridge we need to select with respect to the bridge which is having the lowest ID. So here ID is this one 1, 2, 3, 4, 5. So this is the root bridge, right? So we are selecting the bridge 1 has the bridge 1 has the root bridge, right? Then the second one we need to select the root port, right? So root port, how to select? The port with the least cost path to the root bridge, right? So this is the root bridge, right? So this is the root bridge we are having. So now we need to select the root port for each bridge. So this is the one bridge B4, B3 and B5. So with respect to the bridge, we need to select the root port, right, through which the data can enter. Okay, root port means the port through which the data or the frame can enter into the bridge, correct? So here I have written as R, right? So this is the one root port, correct? So you can reach here with the least cost, and suppose B3 is there, so B3 can have only one path this way, correct? And here, right, before we are having, so there is a only one path is there, so this is the root port, right? And B5 we are having this is the root port, right? So we have selected the root port R, this one B2 1 and B3 1, B4 1 and B5 1, right? So this is the selection of the root port. Now we need to select the designated bridge for each LAN, right? Designated bridge for each LAN and the root port as well, right? So here what we have said, designated bridge has a least cost path from the LAN to the root bridge. So from the LAN, the least cost to the root bridge is this is the one, right? This is the only one we can get. And from this LAN 2, right, to the root bridge, we are having this is the one. This LAN 2 has the two root. One is this way and one is this way. And the least cost is this one, right? And we are having the another one, right? So we are having the another LAN 3, right? LAN 3, again we are having this one root and another root is this way, right? So this is the 1, 2, 3 and this is the 1, 2, 3, right? But it is selected as this one as the root, because why it is selected this one as the designated port because same cost is there. This is the one, suppose the cost is 1 and this is 1 and this is 1, so total 3, and this way you can check this is the 1, this is the 1 and this is the 1, correct? So 3 are there. So we are into the type situations. So during these situations we need to select the route such a way that the bridge which is having the lowest id, that path we need to choose. So here we are having the b3 and b4. So among the b3 and b4 the lowest id is the b3, right? So that's the reason we are selecting the designated bridge for the LAN L3 is this route. Okay. Now we are having the LAN 4. So LAN 4 again it has the two routes. So this is the one, right, and this is the two. So this is the longest route and this is the shortest route. So that's why this one is the we have selected this one as the designated bridge, right? So if you connect the all the route port and the designated port, then we will get this kind of a spanning tree, right? So from the root bridge, so LAN 1 is connected, right? LAN 2 is connected. So here this is the disconnection, dotted line is the disconnection. So in this way we can avoid the looping problem here in the previous one, right? So here there was the looping here, right? And here also some looping was there, correct? And here also the looping was there, right? So three loops used to be there. Now we are avoiding the one loop here, right, and the second loop here. So this is the end. We don't, LAN 3 won't connect to the bridge 4, and similarly LAN 2 is not connected to the bridge 2. So in this way we can avoid the looping problem. This, so this is the closed loop, this is also closed loop. So this is the 1 and this is the 2. So the third case, so again here we are not connected, right? So this is the closed loop 3, right? So that's all. This is how we are getting the spanning tree. Students understood, or you want me to give you one more example? Students,
Yes, sir.
yeah, you guys have understood, or do you want me to give one more problem?
One more problem, sir.
So I'll show in this way. I hope you'll get. This is the LAN 1. LAN 1. And we are having the LAN 2, LAN 3, and so this just for my reference. And so I'll put them so that I can drag easily. Okay, good. So between LAN 1, LAN 2, we are having the two bridges. Suppose this is the one bridge, and this is the another bridge. Another bridge is there. So I'm saying this one B1. So this one is the B1, the B2. So B1 and B2 are there, and I'm having the connection between the LAN 1 is connected to the bridge 1, and also LAN 1 is connected to the bridge 2. Similarly, I want to make a loop. So what I'm doing is I'll connect the bridge B1 to the LAN 2, and similarly the bridge 2 I'll connect to the LAN 2, so that I can create a loop here, right? So this is the one loop. Now I'll create one more loop. So take this, the another bridge. Suppose say this is the B3. So I'll connect the B3 in other side. And this is the B3. So this B3 bridge is connected to the LAN 1, and B4 is connected to the LAN 2. LAN 2. Okay. And what I am doing is I will connect the bridge B4 to LAN 3, so that I can create a loop here. So what I will do, again B3 will be connected to LAN 3. So this is the one kind. Now I'll want to, and I'll create one more loop. So I will take one more bridge B5, I have created, and the B5 I'll connect to the bridge L3, sorry, LAN L3, and B3 I will connect to the L4. L4. Then I'll connect B5 to L4, so that I can create complete loop. So this is the setup. So LAN 1, LAN 2, LAN 3, LAN 4 we are having, and between LAN 1 and LAN 2 we are having the bridge 1, bridge 2, and LAN 2 and LAN 3 we are having the B4, and LAN 1 and LAN 3 we are having B3, and L4 is connected to L3 and B3 and B5. So this is the problem, right? So now the first step, right? So the first step, we need to select the root bridge, right? So root bridge, how to select? The lowest ID of the bridge is selected as the root bridge, right? So I will fill the color as well, so that it will be clear. So this is the root bridge. B1 is root bridge. This is the root bridge. So this is the first step. The second step, I need to find out the root port, root port of the bridge. Only I am saying the bridge. Except the root bridge, I need to select the root port, and which should go to the root bridge with a minimal cost, right? So this is the suppose yeah, I'll give the again the port number 1 and port number 2 for the bridge 1, and bridge 2, this is the 1 and this is the 2, and bridge 4 1 and this is the 2, and bridge 3, this is the 1, right, and give 2 and give 3. Similarly here 1 and 2. So these are the root ports, correct? So the first step is done. Now I need to select the root port, and that root port, except the root bridge, I need to select the other bridges root ports. So from the bridge 2, right? So bridge 2, I can go in this way as well as in this way, correct, to reach the B1. So the cost of the going from the B2 to B1, it's 1 and 1, it's 2, and from here 1 and 1, it's 2, right? It's equal, correct? So during this situation, I said like we need to choose the lowest, port ID, right? So that will become the root port. So this one is the root port first. So I'll just highlight it in color. So I'll highlight it this color. So this is the one root port, right, for the bridge B2, and for the bridge B4 we are having this one route and this another route, right, and this is the lowest cost, so this will become the second route. Are you guys are understanding now? So this is the least cost as well as this. Now comes to the bridge 3, right? We are having this way one and this way another one, and this is the least cost compared to this path to reach the root bridge. So that's why this I'll be writing as the root port bridge, right? So B3 is done, then B5. So B5 we are having this path, and this path, right? So this is the least. If you go this way, right, we have to cover 2, and this way you have to cover 2 to reach here. It's both are equal, and if you go from here to here, again equal, right? So now again there is a tie up here. So in order to break the tie, again we need to use the least, ID. So here is the least port ID is 1. So this you can choose. So right. So these are highlighted are the root ports. Root port 1, and this is also, and this, and as well as this, right? Students, are you understanding? You understood this? Okay, good.
Yes.
So now the first step, root bridge is done. The second step, root port is done. Now we need to find out the designated port, right? Designated port. So designated port bridge, right? So that what we call designated bridge. Bridge which has the least cost path from the LAN to the root bridge. Now we have to consider only the LAN. Only the LAN we need to consider. Till now we were seeing the only the bridges, right? Now we will see only the LAN. So from the LAN to the root bridge we need to go, and that path should have the least cost, right? So the first one from the L1 you can think. So this is the root bridge, right? And you can go this way as well as this way as well as this way also. So least cost is this one, right? So now I will highlight that one. What color should I highlight? Yeah, I'll highlight this color. Can you see the color? Yeah, now it's better. So this is the designated port, right? Designated bridge, right? What we call designated bridge. Yeah, this is the designated bridge. I'll write details here. Designated bridge. Okay. So the path it has to reach to the root bridge from the land, and it should have the least cost. Correct. Now from the land too. So again we are having this way as well as this way and this way. So least cost is this. So I'll choose this. Yes. Yeah. Yep. So right. So land 2 is done. Now come to the land 3. Right. So land 3 we are having the this one path and this is the another path. Right. This is the another path and this is so 1, 2, 3 and 1, 2, 3. Right. 1, 2, 3. Carefully see this is land 3. So one path consider only one cost. So 1, 2, 3 and land 3 to this way 1, 2 and 3, right? So in both the route we are having the same cost. We can choose anyone, but whenever, so how to choose anyone? We cannot randomly choose, right? So we need to break the tie. Next we need to see the lowest bridge ID. So land 3 here is the B3 and land 3 to here this route has the B4. So lowest one is B3. So we need to select this as the designated bridge, right? This has the designated bridge. L3 is done now. Now consider the L4, right? Consider the L4. So we are having this is the one and this is the another one, right? Again we are having the tie up here because this is the 1, 2, 3, 4, 5 and you consider from here 1, 2, 3. Yeah, it's not a tie up, right? It's a 3 from here 1, 2, 3 and from here 1, 2, 3, 4, 5. So this is the designated bridge for the L4. So it's very easy. Right, guys, understood? Understood or not?
Yes, sir.
Okay, great. Now, so wherever it is highlighted, so that is the spanning tree. So wherever it is not highlighted, black color is there, I will remove that one. See? Right, no loop only. So completely open. Right? You guys understood? This and this. Okay, fine. So yeah, so that's all about the spanning tree, right? So I'll just want to introduce the data link layer. So we are not studying the physical layer. We are studying data link layer, network layer, transport, and the application layer, right? So in that, the first, second layer in the TCP/IP or OSI model, it's a data link layer. So the data link layer has a main two important functions. So the first one is the logical link control. So the error detection, error correction, right? So all these functions will be carried out in the logical link control. And in the medium access control, the functions like whether the link is busy, whether the link is idle, whether should I send the data or not. So these kind of information or the functions will be done by the medium access control. So as we are saying that as we are in the second layer of the TCP, that is the data link layer, in that logical link control, so the communication exists here, like transmission of bits, right? So the one device is there, A, and another device is there, B. So the communication establishes, and after establishment, whenever there is a exchange of information, that happens through the zeros or ones, right? Zeros are 1 1 0 or 1 1, right? So it's like a point-to-point communications or broadcast communications will be there here, right? So during this kind of situations, we will get some kind of disturbance from the environment or from the third party, knowingly or unknowingly they will be interfering with respect to this link, right? So those we call the unpredictable, or sometimes you can say the predictable, if the third party wants to introduce some kind of junk information into the our data, right? So those things called predictable changes. So usually we will get the unpredictable changes like the interference, noise, right? Noise is completely random in nature. We don't know what kind of noise we will be going to get, right? So this noise or interference will be completely changing the shape of the signals. Whatever the original signals, right, was there. So if you introduce with this, with some noise, something like this noise, if you introduce, as a result, we will be getting like this kind of a signal, right, which is a not an original, or the shape will be the different, right? So this kind of signals in some of the applications, okay, they can tolerate, and some of them they cannot tolerate even a single bit of error exists into the frame, right? For example, some random errors are available in audio or video. Some one or two or three bits of information got corrupted or got lost during the transmissions. So no problem, we can manage it. But whenever there is a transfer of the text, right, the data, the text, so there we need a very high level of accuracy, right? So there we cannot accept these kind of errors. Even though very small errors is there, but it's a not in an acceptable form, right? So in order to understand what kind of errors are there and how to detect those errors, how to avoid those errors, so these things we will be studying in the future classes. So as of now, I will stop the class. If you are having any kind of questions, I will take up now.